All right, cool. Let's get started. Well, thanks everybody for coming to one of the last conferences on the last day, across the street, top building. I have fantastic cash prizes for all of you. All you have to do is fix 3 issues on the Falco repo, and then that prize is yours. So keep that in mind, guys. So I'm Mark Stemm, and I'm going to talk about how we added support for Kubernetes audit events to Falco. Just a little bit about me. I'm a senior software engineer at Sysdig. I've been there about 3 years, and the first week I was at Sysdig, Laura said, hey, let's go release this thing called Falco, and I said, okay, what's that? And then look where we are now. So we got this awesome stuff. So, and I'm kind of one of the maintainers on it, so it's all my fault, or it's all, I made it all awesome. Either one is fine with me. So if you don't know much about Falco, hopefully you are familiar with it. But if not, let's just do a quick introduction. So Falco is a behavioral activity monitor. And what it does is look for suspicious or other notable activity as defined by a set of rules that it has. Prior to Kubernetes Audit, all of the activity that it was monitoring was based on system calls that came from the underlying code in Sysdig. So a lot of the things that you see in Falco are actually powered by Sysdig's support for interpreting system calls, adding context to them, and having filtering and output abilities on it. And Falco just takes that and builds a rules engine on top of it. When Falco identifies some suspicious activity, it basically can send messages to a number of output channels. And so we have some basic stuff in there. You know, you can write to files. You can write to standard out if you're running it directly. We can go to syslog. We can invoke little programs. So you can use that for all kinds of purposes, like sending emails or posting to webhooks or anything like that. So it's a pretty flexible way to get your stuff from Falco to wherever else you want to get it. And obviously, it's open source. So I'll talk more about it in a second, but we moved it to the Apache license. It's been open source since the beginning, and now it's Apache. So, you know, please make your contributions. Feel free to use it, incorporate it in your own stuff. But if you use it, please let us know, because, you know, one thing we really want to do is build a strong community around this so we can get this thing to really take off. One thing we're really excited about in the last few months is that Falco has moved over to be a part of the CNCF. It's at the sandbox level, which is the entry beginner level, but we'll kind of move up hopefully. You know, we think this is really exciting because we really want Falco to be kind of an essential piece of runtime security for containerized environments, and we really hope that we can get everybody excited about it, get some fantastic integrations going with Kubernetes, and get it really built in there and usable by lots of people. So just a quick example, if you've never seen Falco, kind of what the kind of stuff you can do with it. In the top pane, we've got Falco running. In the bottom pane, we're doing all kinds of bad stuff. So we're doing stuff like execing into a container. You might use that for privilege escalation. We're reading sensitive files below like etc shadow. We're modifying system files like things below /bin and so forth. And for all of that bad activity we're doing on the bottom, we're detecting it in the top because we're seeing all the activity done as expressed by system calls, and basically running that against a bunch of rules, looking for shady stuff, and then sending you messages when the shady stuff happens. Okay? So let's talk a little bit about how Falco is kind of architected, and that'll kind of set up the second half of the talk pretty well. So in the lower left, right here, we've got a kernel module, and the kernel module taps into the stream of system calls on the machine. And we see every system call that's running. You know, it doesn't matter if it's in a container or not, or directly on the host. We get all the system calls. We take the system calls and we turn them into a little system call event object. We bring that up to user space, and the job of user space is basically to add context to it. So the thing we get from the kernel module is pretty basic. It's like a thread ID, a syscall number, and the arguments. But from that, we start adding context. So we know that thread ID 10 is actually a thread in a process called Apache. And so we'll add context saying, hey, for this event, the process name is Apache. If this is running in a container, we'll add container level information. We'll say, oh, this is running as a part of a container with a given ID. Here's the image that was used for that container. Here's the mounts that container has. And we add all of that as context to that system call event. If it's running in a containerized or orchestration environment, we add more context. We say, hey, it's a part of this pod, a part of this deployment, part of this namespace. We add all of that context to the object. So now we have this really rich view of the activity done as a part of that system call. So we can know who did it, what they're doing it on, and where in your environment you're doing it. So it's pretty rich. Once we have these system call events, we basically run it through a rules engine, and that's all provided by Falco. The rules, like I said, they kind of look for suspicious or other notable stuff. We take every event, kind of match it against the rules, and when an event matches one of the rules, we send it to one of the outputs. And then you can construct a special output string that's got a mix of stuff that you type in and stuff that comes from the event, and that's what goes to the different output channels. So let's look at very quickly what a rule looks like, and then use that to kind of talk about how we extract this information out of the event objects. Okay? So this is what a Falco rule looks like. It's got a name, a description. This condition piece of the YAML is basically a filter that gets matched against all of the system calls. So in this case, the rule is looking for writes below a binary directory, and what the condition does is says, is the event type open? So is it an open syscall? And is the directory component, that is the thing being opened, just take the directory part of that, does it match either bin or user bin? So get some matching stuff. When it matches, we generate this output string, which again is a mix of plain text and stuff that comes from the event. That's the little percentized thing. You can tell we're C programmers because it's all printf for us. If it was Go, it'd be like the brackets and stuff. That's kind of it. So let's talk about how we kind of can take this and adapt it to use a different kind of event than the system call events that we previously used with Falco. So the heart of it is that we have these fields that basically reside in the condition expression or in the output expression. And for each field, we basically go over and interrogate the system call object and say, what's the value of this field? So in this case, event.type, you go over to the object and say, what's the value for the field event.type? In this case, it was open. So we find out it's open, we go look at the logical expression of the condition, and we keep going because it matches. Similarly, if we want to look at the directory, it's another reaching out to the object to say, hey, what's the what's the value of the field called fd.directory? We get that out, see it's /bin, matches these values, and then we match the condition. Now it's time to look at the output, to generate the output string, same deal. We just got these fields, grab it out of the object, and then that gets stuffed into the output template to figure out what message we want to send off. Same thing, command line fd name. So the nice thing is that we realize that there's a lot here that we can reuse if we want to use other event streams. All this stuff for the YAML and the logical operators and naming the fields, extracting the values, we can make that pretty general purpose. And all we have to do is make up a new kind of event object and new kinds of fields that know how to extract stuff out of the event object. If we have that, we can reuse all the framework that we already have in Falco. And that's what we did for Kubernetes audit events. If you don't know what Kubernetes audit events are, let's talk about it a little bit. It's a new thing in Kubernetes 1.11. And what it does, it's basically an audit log that gives you a chronological set of records that document all the changes that happen to your cluster. The nice thing about Kubernetes is almost all of the activity goes through the API server. So that's a nice point where if you can just create an audit log of what happens there, it's going to reflect almost all the changes that are being made to your cluster. So when you set up audit logging for Kubernetes, one thing you provide is basically an audit policy. So this isn't a Falco thing, it's just a Kubernetes thing. You basically tell the cluster, here are the kinds of events that I want you to put in the audit log. So you might say things like, only tell me about deletes. Only tell me about things that happen to deployments. And there's a rich documented framework for that's really flexible and giving you the kinds of stuff that you want out of it. In the Falco repo, we have an example audit policy, which is the one we've used that we think would be a good reference if you want to kind of use it in conjunction with Falco. Of course, you can add whatever you want to it. So once you have this audit policy that controls what events are going to come out, you have to decide where they go. So you have a couple options there. You can write them to a log file. Simple log file rotates every once in a while, like you would expect out of any like web server log or any of those audit type logs. And you can also post it off to a webhook. So you can give it a network endpoint and said, hey, go over to this IP or service or host name and on this port, and here's the path you should use. And it just batches it up. It's got a little like Nagel algorithm type thing where it like batches a little bit, but then if it's been too long, sends them off. And it just posts it to HTTP, so pretty simple. And that's the mechanism we actually used in Falco. So just to give you an example of what one of these audit events looks like, I simplified it a little bit because there's actually a lot of stuff in there, but this has all the main pieces. So an audit event has a timestamp. There's a stage, because for the audit logging, you can actually check it at different points. You can check it like as they're making the request, after they're making the request, and as the response goes out. So that's what that stage means. So there's always a verb, so it's like what action you want to take on the target object or named object or something like that. In this case, this audit event represents deleting a namespace. So in this case, the verb is delete. We have a URI. We can say who they are. So they have a username. It could also be like service account information. We have the response status. So it's HTTP level responses, but they map to the expected yes, no kind of thing. In this case, it's referring to a namespace. So that's what object ref is for. They all have unique IDs, so you can just unambiguously identify them. And they have information about like what authorization decisions it had to make and whether it was allowed to do that. And that stuff's included there too. So it's a pretty rich set of information about like what they tried, what the result was, and what happened as a result of it. Going back to our architectural diagram, let's talk about how we added support in. So step one, we added an embedded web server to Falco. So just nice little Civet web thing that can basically, it sits there and listens for posts on one and exactly one endpoint. And it's configurable and the port's configurable, but that's all it does. No gets, nothing else for now. Once we had that, you set up your Kubernetes API server, you set up the audit policy to get the events out, you set up the webhook-based audit communication, and then that goes to Falco. Falco gets all of the JSON objects. We do some simple transformation, a small amount of like repackaging to turn it into the objects we need internally within Falco, and then we're set. Once we have that, we can use the same rules engine that we already had, all the YAML, all the logical expressions, all the in operators and equal, not equal, all that stuff, all works just the same, but it's a different stream of events, and it's actually a different set of rules. They're just running in parallel on parallel event streams, both system calls and Kubernetes audit activity. A little more detail on how we actually implemented this in Falco itself. Falco is pretty much all C++ with a smattering of Lua for kind of setup. So we already had this object that was a syscall object, C++ object. We just put another object on top of it and made a bunch of virtual void methods. So we just defined some interfaces that say, hey, if you want to be a generic event, here are the things you have to do. You have to give me a time back, and you have to have this ability to extract a value of a field. You give me the field name, and I'll tell you what the value of that field is out of the object. We ended up using JSON pointers to do the extraction, just because it's a convenient way to do it, and I'll talk about that in a second. And now, once we had that, we were pretty much set. And then we wrote a bunch of new rules. So there's a new rule in 0.13.0 Kate's audit rules.yaml, runs parallel to the main rules file that we already had. And all rules now have a source. So by default, the source for a rule is syscall, which means the system calls, the ones we already had. But you can have another source, Kate's audit. And if you have a source of Kate's audit, you get the events that come from the API server. Otherwise, you get all the events that come from the system calls. It didn't really make sense to mix them because like all the fields don't really have like cross meaning. So they're just two parallel streams of events going through one rules engine where they pick off their subset of rules and do all the matching. Okay, so let's just do a quick summary of what JSON pointers are because it's a convenient way to access this stuff, and we kind of build on that to define our field names. So JSON pointers are just a way to extract the value of a given property path in a JSON object. If you know XPath, like you're old like me, it's that kind of stuff, but it's for JSON objects. Ducey's laughing up here. I'll drop some motif references next, okay? So you got a JSON object on the left, and then we'll just kind of say like, oh, okay, let's go through some examples, right? So if I want to get the value of the property called foo in the object, you just put a string that says /foo. Pretty easy, right? If you have a nested object, you just keep going down in the nested expression with path separators. So if you want to get the value of the baz property within the object, that is the bar property, you say /bar/baz, and then you get t. You can do array indexing. That's just, you just do that by doing slash and then a number. And then it'll say, hey, assume this thing's an array, give me the 0th value out of it. And you'll get 1 in this case. Okay? So pretty simple. Looking back at our Kubernetes audit event, the way we can extract this stuff is kind of the same way with these JSON pointers. So if we want to figure out what the verb is, we just make a JSON pointer that's /verb. If we want to figure out what the status code is, we look at response status /code. So it's a pretty nice, flexible way to get pretty much anything we want out of these JSON objects. There's a little bit more stuff within Falco. We actually have little micro functions that can do some simple aggregation and filtering. Like you can say, like, look at a whole array at once and only give me certain values, or check to see if it has a value. But JSON pointers are the real heart of it, that really extract the stuff that we want out of it to define these fields. So there's a few fields that we created in order to add support. The first one is jevent.value. This is kind of your general purpose one. It's always there, and you can always use that to get something out of the object if nothing else works. So jevent.value, bracket, and then you just put one of those JSON pointer strings in there. And then you start at the top, work your way down, get that, whatever value comes out, that gets matched in the filter or gets put in the output string. Everything has a time, so jevent.time is it extracts a specific accurate time out of the JSON object, but we just have it as a direct thing. And then the next thing is we have all these basically aliases or macros, because it'd be kind of awkward to write jevent value blah 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 or jevent value. It'd get really awkward and clutter up your rules file. So we made it a little bit more concise and gave you some shortcuts to basically have short strings that represent long pre-canned JSON pointer expressions. So some examples of them are k.verb, k.uri, k.user.name, k.target.resource, and so forth. And they're basically just macros that map one-to-one to a given jevent.value. So k.verb is equivalent to writing jevent.value bracket verb. K.target.resource, same thing. Okay? If you want to know what all the rules are, or all the fields are, you can look at the wiki, or you can just run it live. So Falco --list equals Kate's audit will just dump out all the fields. If you know Sysdig, it's very similar to Sysdig-L. Print out all the fields. So you can kind of get an idea of what you can get out of these objects. Okay? So let's look at a rule, right? So how are we doing on time? We're doing good. This is kind of like one sample rule, and it's supporting macros. If you don't know Falco, Falco has rules, but it also has macros for code reuse and lists and stuff. So we just got all pieces here. So going top down, so the first thing we do is we define a macro that's called contains. Oh, the goal of this rule is to look for, like, somebody created a config map and you put your AWS key in there. Like, don't do that. But if you do, then we got a Falco rule to slap you on the wrist, So we have a macro that says contains private credentials. And what we're doing here is we're just specifying a little condition snippet that says k.request.configmap.object, which is basically the operation when it referred to a config map. Look at the object, which is just a string when we grab it out. It says, does it contain AWS access key ID? So I guess if you're just evil enough, you'll put your password in, but you'll spell it wrong, and then we won't get this. But if you're dumb enough, you'll probably still call it password, so we'll get you. The next macro is config map, and we're saying k.target.resource. It's saying the thing that you're acting on is a config map. We have a macro called modify, which looks at the verb and says, is it create or update or patch? So is it some modification type thing to the config map? Bringing it all together, this is where we tie it together in the rule. So we have a rule that says create config map with private credentials. And the condition is just the combination of these macros. So config map, you're acting on a config map. Modify, you're doing a modification or creation of one. Contains private credentials. When we look at the config map you're giving us, we look in there and we see something that looks like it might have private stuff in it. Take all those three, put it together. If it matches that, then here's your output string. Kate's config map with private credential. And again, we're giving you a mix of information that comes from the text and also the audit event. So we'll be able to say who did it, the k.user.name, what action they're doing, k.verb, the name of the config map, and the contents in the config map. So very similar to what we have with system calls, but working on these like cluster-wide Kate's operations instead. All right, so let's do a demo. You know, that's the most fun, right? Okay, so I got my cheating speaker notes there. I'm going to flip back and forth. Okay, so we'll get Falco running in the bottom. I think you guys can see this. And in the top, we'll just start doing stuff and see what happens. So the first thing we'll do, let's just create a simple deployment, based on Nginx or something. So in the rules file, we actually have a few different classes of rules. So we have like one class of rules that looks for suspicious stuff that you probably shouldn't be seeing anywhere. We really take care to use the severity field of these rules. In Falco rules, they have severities that go from like debug up to error. And so we try to make sure like the warning really reflects like how bad we think the thing is. So the first class is generally like warnings or errors. We have another class of rules that are like, hey, these are just things that are happening to your cluster. So basically when objects get created or deleted, we have stuff for that. That stuff's more like notice or info level. And then we have a third class, which is basically whatever object comes in, we just print it out. That rule is actually off by default, but it's debug severity, so you can turn it back on if you want. All right, so we'll create a deployment here. And then Falco will detect it. So in this case, it was info saying, hey, somebody created a deployment. We can see what the user is, what the name of the deployment is, the namespace that we're in, what the response was, and the auth reason and that kind of stuff. So let's delete that deployment. Forgot. Everything's in my demo namespace. So we're going to delete the deployment. Same thing happens down here. We can see that, hey, somebody deleted the deployment that we just created. You can do the same thing for a service. So we have support for all the major classes of objects in there. So if we create a Nginx service, it works. If we delete a Nginx service, it works. And so there you go. So we get all that basic stuff. All right, what was I going to do next? Okay, so let's show that config map example again. So here's a sample config map that just in YAML. And you can see here this, yes, I really did put my AWS access key in. It is called my access key, so I don't know if AWS will like it, but we'll just do it anyway. So we'll create this. So we created the config map, and then Falco detected it because we saw the audit event that reflected the config map being created, all the fields that we had, looked in the config map contents for something called AWS access key. When it did, we sent you an information about it. You can see here the severity is warning because it's probably shadier than just somebody creating one, right? What was it going to do next? Oh yeah, let's try our, one of the things we always show with Falco is execing into a container. So we'll do the same thing over in Kate's audit land. So let's create our Nginx deployment again. Wait for our pod, and so you can see it created the deployment, right? Okay, and then we'll exec into it. Demo, IT. So here we did kubectl exec into the pod, and we detected that too. The reason we really focus on this like kube exec stuff is it's like a a pretty powerful mechanism for privilege escalation, which is, a great way once somebody gets in to start getting more power, right? So if you can exec into a pod, you're going to basically inherit all of the permissions that you've granted to that pod. So if somebody can get in, they can do, and that pod is really powerful and has lots of privileges, they're going to be able to do most of those things as well. So it's a great way to get in. So, again, we saw that the exec happened. We checked to see, well, yeah, that's all we did for this one. It was at notice level and say, hey, somebody execed into a pod. You might want to check it out. All right, let's do some service account stuff. So what did I call it? So let's try something where we create a service account and accidentally or negligently give it too many permissions. So we'll create a service account called bad account. And then we'll take that service account and create a cluster role binding that binds it to cluster admin. So cluster admin has lots of powers. You probably don't want to do that following the principles of least privilege. So if you did do that, Falco would notice that and send you information about it, saying, hey, somebody created a cluster role binding to the cluster admin role. Maybe that's something you didn't want to allow, and you should check it out. Another thing we can do is, let's look at this one. Overly. So here we have a cluster role and cluster role binding where we're going to grant too many permissions to a given cluster role, or we're going to define a cluster role with too many permissions and then grant it to a user. So let's say you use wildcarding, like, oh, I'm too lazy to name the resources that this guy can read, so I'll just do star. Well, don't do that either. And we have some rules in Falco that say, hey, if you try to do that, we're going to let you know that somebody's doing that. So here you can see the cluster role binding was created, but when you look at the cluster role, it has something with a wildcard. So we're basically looking at the rules that are defined by the cluster role, seeing if there's a wildcard in there, and if there is, we'll let you know about it. Similarly, if getting back to that pod exec thing, if here, let's just take a look at it. If you didn't grant anybody pod exec permissions, but you did grant them the ability to grant more permissions, well, the first thing they'll do is give themselves the ability to exec into pods. So this is a cluster role that allows pod exec. The way that works is you just have a resources called pods exec and a get on it, and then that allows you to do exec. So if you try to create one of those, again, we notice. So we see that you created the cluster role that had the ability to do pod execs, and we let you know, hey, somebody did that. Maybe you should check it out and keep an eye on it. And I think I got one more. Yeah, OK. So maybe you're running platform as a service, and you're trying to keep people off in their own namespaces, but you don't want to allow arbitrary namespaces because maybe you don't want to let the crypto miners in. They're smart, and they'll put stuff over, and maybe they'll put it in a namespace, secret namespace. One of the things that we have in Falco is that you can define a list of the namespaces that are allowed for you. And you can turn the rule off. You can also say everything's allowed. But by default, we only have a few namespaces that you allow. And if you create namespace. So if you created that namespace in order to hide your activities from everybody else, we notice that. Because we have a list of allowed namespaces, you create something outside the list, and we let you know about it. Okay? So obviously there's tons of other rules that we have in there. And one of the things we really want, because we've only released this in the last month or two, and we really want feedback on what kind of rules can we add? Are the rules that are in there going to work for you? That's something where we took a stab at it, but we'd love to get feedback from you guys on rules you'd like to see or use cases. So please let us know about that. So we'll wrap it up real quick. Here's all the links to all the things. Falco.org is our new website under the CNCF, so it's divorced from Sysdig. So you can go to there to get all these other things. The public Slack, I guess, is still under Sysdig, but there's a channel there called Falco. We all hang out there, try to answer questions. If I know some people answer each other's questions, which is even better because then I don't have to answer them. So go there if you want to learn more about it. If it's not working for you, we'll try to answer. We got a bunch of blog posts on the sysdig.com website that talk about use cases with Falco, sample integrations, that kind of stuff. It's a great way to figure out like, oh, how can I do Falco to detect this and that kind of stuff. As a part of the CNCF migration, we've moved over Falco to its own organization, Falco Security, so it's not under Dreos anymore. So Falco Security/Falco. We got a wiki there that describes how to use Falco. There's a page there now talking about Kubernetes audit support, so how to get all this stuff up and running. Also, you can always run Falco as a container, and a daemon set, of course, for Kubernetes. And we just moved it over to Falco Security. So again, it's its own organization, not under Dreos anymore. All right, thanks a lot.